Hi, we're Team AGLO presenting our solution to Bill.com's data challenge. I'm Chris.
I'm Colter.
I'm Matthew.
And I'm Ari.
In order to better understand business vendor relationships, we used a dataset of 430,000 card transactions between federal agencies and vendors. We applied an iterative agglomerative clustering method to group similar transaction patterns. Based on these clusters, we are able to accurately identify and recommend vendors that similar agencies frequently interact with.
Our metric for similarity was simple yet accurate. For any given transaction, we compare the spending amount to the average money spent by the agency. Above average transactions indicate stronger relationships. We also take into account the number and frequency of interactions. This similarity metric yields strong results, as we'll demonstrate soon, but other weighting functions can easily be substituted if the need arises. Before analyzing data, we use simple text analysis to eliminate duplicate entries. Next, we use an iterative agglomerative clustering method.
This algorithm starts with a candidate clustering for vendors. Based on this clustering, it finds the average weight between all vendors in a cluster and each agency. The two agencies with the smallest total difference in corresponding edge weights are then combined into a cluster. Once agencies are clustered, the process repeats in the other direction, using these agency candidate clusters to generate new vendor clusters. The algorithm iterates until convergence is observed. We include one easily tunable parameter to dictate sensitivity to cluster size. By tuning this parameter, a business can generate broader or more narrow groups based on their needs.
To demonstrate the versatility of our algorithm, we ran it both on a subset of individual vendors and the full set of broader vendor category descriptions. We noticed consistent similarities within clusters, such as employee resources in this first agency cluster and physical equipment in this vendor cluster. Taking a closer look at the contents of a cluster, we see that the algorithm successfully grouped departments despite their polar differences in budget. So our model detects spending patterns that are not immediately obvious, demonstrating its usefulness as a recommendation tool. To visualize wider group connections, we use a Sankey diagram. Here's a small snapshot of our vast network, demonstrating the strong connections certain clusters on the left have with certain clusters on the right. For example, agency cluster 1 at the bottom clearly has a strong relationship with vendor cluster 6 on the right.
We believe our solution is not just a theoretical tool and can be broadly used by institutions. First, this technique can easily be written to execute in parallel. For this demonstration, we clustered a subset of vendors included in the dataset. In a setting with access to more computing power, the algorithm would easily extend to quickly and effectively analyze large datasets. Additionally, the high tunability of our similarity criterion and clustering function means that our method will quickly improve with user feedback. Thank you for your time and consideration.